My name is William Harris. I'm an engineer. My degree was in engineering physics. My specialization was in spacecraft systems. I've had many courses in orbital mechanics and spacecraft design. Today, I want to explore this comparison of the predictive power between the globe model and the flat Earth model. What do they predict and what do we observe in reality? The first point I want to make has to do with one of the most primitive proofs of a globe. It is the experiment from Eratosthenes. Essentially, the globe and the flat Earth both would agree that as you go up in latitude across the Earth, a shadow would increase its angle more and more as you go higher in latitude. The question is not will it increase in angle, the question is what trend does the increase in angle take? How much does it increase in angle over the latitude? The globe would obviously predict that at the pole, it would be a 90-degree angle. It would be an infinite shadow. But in the flat Earth, it could never be a 90-degree angle. It would never be an infinite shadow, obviously. So the question is, which one do we observe in reality? Of course, the globe is correct. We see these infinite shadows all the time near the poles. Next, star movement. A globe and a flat Earth model both agree that in the North Pole and point C, you would see a circular pattern of stars as they move across the sky. But when you get to the equator on a globe model, you would see stars go from east to west in a straight line across the sky. And on the South Pole, you would see them go in a circular motion again, but in the opposite direction of the North Pole. But in a flat Earth model, you predict that on the equator, you would see not straight line of stars going across the sky, but a curve of stars going across the sky on the equator. And at the point D on the South Pole, you would still see a curve of stars going across the sky, but just more straight, so definitely not a circle pattern. So the question is, which one do we observe in reality? Oh, we do observe the globe in reality. Sounds great. So we talked about star movement, now we talk about planet movement. So assuming we were on a globe that is orbiting a star, and there are other planets orbiting the star, we would predict that we would see these other planets and observe specific type of motions from them from our point of view. A really identifiable one would be retrograde. We would see this very specific pattern that you see on the GIF on the side of my screen if we were in that situation, that's to say. And what would flat earthers say about planet movement? They would say, I don't know what planets are. We don't know what those things are. We just lights moving across the sky. There's no way to know what they are or predict how they work or have any explanation for them. So which one has better predictive power and which one do we observe in reality? Of course, we do see planets having retrograde motion, exactly how the globe model would predict. Next. Lunar eclipses, it's a crowd favorite. Obviously, the only object that will always project a circular shadow is a sphere. And in a globe model, you would predict that you would have lunar eclipses, and those lunar eclipses would always be circular every single time. The Earth is always at a different orientation for every lunar eclipse, so it would be a circle every time, no matter what the orientation. The penumbra and the umbra would both be circular. And we would predict that we could pinpoint exactly when it would be observable and where exactly it would be observable down to the second. That would be predictable if we were in the globe. Now, if we're in flat Earth, what would they say about lunar eclipses? They would say, I don't know what that is. I don't need to explain what that is. There's no way to predict what they are or how they work or why they work. So which one has better predictive power? The globe does. We do predict these orbits down to the second, I might add. We do predict these eclipses down to the second in reality and where they're observed, obviously, as well. Constellations and the North Star. Both the globe and the flat Earth theory predict you will see the Polaris, the North Star, in the North Pole. But when we go to the South Pole, on the globe, you would see the Southern Cross on point D and point E. But on a flat Earth model, you'd predict maybe you would see the Southern Cross on point D, but you couldn't possibly see it at point E, right? Because it's on the opposite side of the planet. So what would you see in the night sky of point E? Well, they don't have really any explanation of what they would see because it would have been obvious, but there is no explanation for it, what they see there. They can't see the Southern Cross, that's a guarantee. So which one do we observe in reality? Yes, we can see the Southern Cross at point D and point E. Flight times. So This is real flight data observed in real time from flightaware.com. I encourage everyone to go do this and test these data points live. There's thousands of them every day. Chile to New Zealand is a 12-hour flight. It goes 7,000 miles. Seattle to London is a 9-hour flight. It goes 6,000 miles. It's not perfectly linear correlation between the time and the miles, but it's still generally reasonable, especially with the currents of air that go in near Chile in the time of year. So this is what you would expect if we were on a globe. If we were on a flat Earth, I can't tell you exactly the travel times they should be, because on a globe, they never have a good scale on exact distances for what a flat Earth map would have, because the geometry doesn't make any sense. But you can obviously see that Chile to New Zealand would be about 3 times longer than Seattle to London. So is that what we see in real life? Does Chile to New Zealand have a 30-hour flight? The answer is no. The flight was 12 hours, not even close. The Coriolis effect. The globe has a Coriolis effect that dictates hemispheres on the hurricanes in the north hemisphere and hurricanes on the southern hemisphere will rotate in opposite directions, because the equator of the globe is spinning and moving much faster, and the wind is moving faster at the equator than it is at the poles. So it would be different from the north hemisphere versus the south hemisphere. For a flat model, you could argue there shouldn't be a Coriolis effect. But assuming there is, for some reason, a Coriolis effect, it would not change between the north hemisphere and the southern hemisphere. It would be consistent for both. It would be the exact same. Everything would be turning in the same direction for hurricanes. So the question is, which of these two do we observe in reality? Of course, we see the globe Coriolis effect in reality. Now, this is my last evidence-based argument. This is my favorite one. It's for gravity, because it is the most observable, consistent topic in all of science ever since the beginning, is just gravity. So you can observe it every single day, all day, from a micro scale to a macro scale. Micro being you throwing a ball to your friend with projectile motion, or tossing a nuclear bomb from one country to another using projectile motion and gravitational equations. It can also explain the existence of an atmosphere on a ball in a vacuum, because an atmosphere, although it is very, very low density, it is still made of atoms, which still have mass, and mass is attracted to mass with gravity. That is the rule. So yes, the atmosphere will cling to the globe because the globe is a very massive object. That is why an atmosphere does not disperse into outer space. So it can predict we would have an atmosphere. We could predict the motion of the Earth around the sun and the motion of the moon around the Earth using gravity. We can predict the tides of our ocean using gravity, because the tides of our ocean is a product of the gravitational pull of the moon on the liquid on the ocean of our planet. We can predict the Earth and all other planets' motion in our solar system, as well as all the asteroids and comets that we see orbiting our star. We can predict the motion of the stars that orbit the galaxy and the motion of all the galaxies in our universe by using gravitational equations. It is the most validated concept in all of science, and to deny its existence is for a fish to deny the existence of water. So what is the predictability of the flat Earth when it comes to something like this? Nada. They don't have anything to predict these level of phenomena. So I've finished with my evidence-based arguments, and now I want to talk a little bit, change it up, and talk about psychology. I want to talk about the psychology of flat Earth, and talk about why in the world does this theory still stick around? It cannot be because of evidence. It is not because of evidence. Because every single opportunity that it could have to prove itself true, it fails and proves the globe is true every possible time. So why could it still exist? If it's not for the evidence, then why? It is because it's about the passion behind the idea. Because the followers of Flat Earth are extremely passionate people. The followers, I want to characterize and profile the followers versus the leaders of Flat Earth and contrast them. The followers of Flat Earth are extremely passionate people. They're insatiably curious. They always want to know why, and the next step, why, and that's awesome. They can also have a distrust of scientific institutions, and they can potentially have predispositions to believe in conspiracy, and maybe have a little bit of paranoia as well. Now, let's contrast that to characteristics of flat Earth leaders. Flat Earth leaders are extremely charismatic and very articulate, as my friend Wits is. A very charismatic and articulate man. But they are also extremely arrogant. They believe they know everything. They are intolerant of criticism, as that would project weakness to their followers. And they're exploitive of their followers. They will ask their followers to support them in their endeavors. And then we need to ask, why? What is the incentive these leaders have to push misinformation that they know is false? Because these people are smart. So they know they're not pushing a good faith argument. But why would they want to do that? What incentive do they have? Well, number one incentive is pure fellowship. Having people be loyal to you and follow what you say is attractive. Having attention is attractive, even if you're not following them. I'm giving him attention right now. And that's another incentive they can have. A sense of superiority over their followers. When someone listens to you, that's always nice. And of course, they can make some money along the way as well. So if you have listened to nothing I've said tonight, if you have listened to nothing, just listen to this last part. This is the part that I want to make crucially aware of. This is the most important bit. No individual understands all of science. None. Despite what Witsit will tell you. No individual understands it all. An astrophysicist doesn't understand everything about quantum mechanics, and a quantum mechanist doesn't know everything about astrophysics. So when you are faced with an unintuitive or unexpected fact, do not throw the baby out with the bathwater. Do not throw the universe out with a misunderstanding. Push Occam's razor to the forefront of your mind and understand it's far more reasonable that you don't have all the information, rather than the model for the entire universe is wrong, and that all scientists, almost every scientist, are liars or ignorant. And my last statement is, flat Earth leaders do not have some special power of understanding things better than everyone else. And please do not fall prey to their con. Thank you. That's my time.
All right, there was a lot there, but for one, I want to see if we're going to keep the same energy of Occam's razor, which is that which requires the least amount of assumptions. That, of course, is terrible for the globe model. But one thing I want to cover real quick that can just end this whole entire discussion, it actually overlaps with the gravity thing. He said gravity is mass attracting mass, which is objectively not the case anymore. It can't be the case. The Earth quite literally cannot be a ball that orbits the sun with mass attracting mass. Newtonian mechanics can't exist. And I'm sure we'll get into that. And I don't know why people keep invoking it. But one thing I want to point out that I think is an easy way to kind of go ahead and end the conversation is we have an electric field on the Earth. Okay. So we have a uniform electric field. It's vertical on the Earth, and you can measure the electric field, right? It has equipotential lines. It's 100 volts per meter, meaning there's an equal increase of potential every 100 or every meter. It's 100 volts, right? So there's equipotential lines within a vertical electric field on the Earth, and it's uniform. Okay, this is physically impossible on a sphere. You can take a conductive sphere and put it in an electric field, and because the charge is distributed radially, it will not be uniform. This is a fact. You cannot have a uniform electric field on a sphere. So the very electric field we observe on the Earth proves that the Earth is in fact not a sphere, because again, there will be spherical radial distribution of charge. What you would have is concentric circles serving as your equipotential surfaces or lines, and then you would not have a uniform electric field. Now, just to read Feynman here to explain it, another thing that can be measured in addition to the potential gradient that we just discussed is the current in the atmosphere. The current density is small, about 10 microamps, crosses each square meter parallel to the Earth. The air is evidently not a perfect insulator, and because of this conductivity, a small current caused by the electric field we have just been describing passes from the sky down to the Earth. Okay, and you can measure it, you can run a generator off of it actually. Now, the question would be, if there's constantly a downward electric current on the Earth, would that create a downward bias? Would downward electric pressure be caused by the downward electric current? The answer is, of course, yes. Yes, we would have a downward bias because there's always a downward electric current. To get more specific, although the electric current density in the air is only a few microamps per square meter, there are very many square meters on the Earth's surface. The total electric current reaching the Earth's surface at any time is very nearly constant at 1800 amps. This current, of course, is quote unquote positive. It carries a plus charge to the Earth. We have a voltage supply of 400,000 volts with a current of 1800 amps, a power of 700 megawatts at any given time. Now, that's assuming the size of the Earth, it's actually greater than that. So to kind of break this down, I hope everyone's following. People refer to the fact that things fall as gravity. That is allegedly the effect of gravity. That is little g. It is 9.8 meters per second squared. That is not gravity, as in the cause of things going down. It is things going down. You can actually solve for that with kinematic equation. You can actually solve for that using Coulomb's law. There's an equivalence that has been proven in the electromagnetic nature of gravity, a paper written by Konstantin Meis, who sat on the board of Nuclear Physics Institute, right? That you can actually have an equivalence with electrostatics. Now, important to note, everything does not fall at 9.8 meters per second squared. That is a misnomer. People are taught everything falls at the same rate and mass attracts mass. It's a very simple layman way to explain things to people when they're younger in school. The reality is things fall at different rates. What a coincidence that the electric field creating the electric current is very nearly constant, just like the rate at which things fall. So that right there explains things falling on the Earth and why there's a downward bias, why it's nearly constant, but it fluctuates. Gravimeters have proven that things fall at different rates during thunderstorms, and mass and quote unquote gravity have been excluded as a possible explanation. I have all of these papers. I'll drop them as we requested. In addition, so that gets rid of the spherical claim. You cannot have a uniform vertical electric field with equipotential surfaces on a sphere. That's physically possible. That gives you the downward electric bias that's measurable, showing things fall and change at which rate they fall based on that objectively. So now you're going to have to claim there's something additional there that you can't verify, but we can actually verify our position based on empirical evidence. Let's use Occam's razor. Remember, that which requires the least amount of assumptions. So we're just going to go with the actual evidence. And also, in order to have a vertical electric field with equipotential lines, you actually are going to have what's called a Gaussian surface. And to quickly explain that, and we can get into it, in Gauss's law, you have what's called Gaussian surfaces, and typically they're used as mathematical or hypothetical constructs. But when you're making a physical demonstration of, say, a uniform electric field, you're going to need real physical plates to serve as those surfaces, right? And they have to be parallel to each other, and they have to be perpendicular to the field. Well, on the Earth, we have a vertical electric field. So what is perpendicular to vertical? It is, of course, horizontal. So in order to have the actual equipotential electric field we have, there has to be some type of containment above us. It has to be parallel to the surface, and it has to actually be horizontal. And this is just facts. So that argument right there, that fact alone, gets rid of the spherical geometry claim. It gets rid of the quote unquote gravity claim, and it gets rid of the we live in a ball, I'll live on a ball in a vacuum claim. Okay, that's 6 minutes, and we can get into that. And again, this is Feynman Lectures. It's 9.1, I believe, and it's about atmospheric electricity. You can check it. You can check the measurements yourself. You can go out and verify it yourself, and you can run generators off of it. So for the last few minutes, what I'm going to do is cover a couple things that he said. Retrograde motion is not exclusive to the Earth orbiting the sun. In fact, in order to think that it was, you would have to not believe in the current model, which uses relativity and actually says there's a kinematic equivalence between a geocentric stationary position and a heliocentric model, meaning all planetary motion, all geometric patterns are equivalent in both models. They're equally valid. Einstein will tell you this point blank in all of his papers. He said it. So there's kinematics, how bodies move in relation to each other, and then there's dynamics, which is the supposed force that causes them to move that way. Okay, gravity would be the claimed dynamics, and then kinematics is just how they move. Retrograde would be a kinematic observation, right? The planets look like they go backwards. Now, of course, on a stationary Earth, there are multiple explanations, one of which is we measure the planets in relation to the background stars. So if the planets were to actually just slow down, on occasion, they would look from our perspective to be going backwards in relation to the background stars. There's a much more popular one that's been known about for a long time, which comes from the Tychonic system. That's Tycho Brahe, which is where Kepler and everyone even got their data in the first place, right? And Tycho Brahe, or a neo-Tychonic system, would say that the planets move around the sun as that entire system moves around the Earth. Then you would have the exact same explanation that a heliocentric model has, which is it looks like they're going backwards because they're moving in relation to the sun, right? And then you have internal planets, etc. So there's a kinematic equivalence with retrograde that isn't exclusive to the Earth flying around the sun whatsoever. And in fact, the Mercury's perihelion shift shows you that their model doesn't even work. Gravity doesn't even work. And it still hasn't been explained to this day. Okay, and we'll get more into this stuff hopefully, but lunar eclipses, he said that the only shape that can have that is a sphere. You can, of course, put anything in front of something that's taking some type of spherical shape, which could be plasma. If you look at light from a distance, it looks like a sphere, right? It has a radius of light. So any light source from a distance is going to look like a sphere because it has a radius of light, right? Illumination. Same with the planets and everything. But that aside, you could take a cylinder and move it in front of the moon, and it would create a circular shadow. This has been replicated many times. If you've never heard of it, it may sound unfamiliar to you, but it is a fact. You can take any shape and move it in front of it and cause a circular shadow. And actually, lunar eclipses debunk the globe, as we have solennilian eclipses where the sun and the moon are both above the Earth during the eclipse, when supposedly the Earth is blocking the light from the sun, casting a shadow onto the moon, which is a geometric impossibility. This is another time where we'll throw Occam's razor out, I'm sure, because Occam's razor is the globe's worst enemy. North Star cannot be seen from super far south. That's correct, because you can't see forever on a flat Earth. And whenever all these things were called predictions from the globe, they're actually just, we looked at the sky, we recorded it over hundreds or even thousands of years, and then we crafted a globe Earth model based on the celestial observations. That's quite literally how we made it. So that would be the opposite of prediction. That would quite literally be the opposite. So if you say, hey, look, I'm going to look at all the sky and then make up a model in my head of the Earth being a globe, then I'm going to say, hey, look, the globe predicts what happens in the sky. That is hilariously backwards.
That's awesome.
I still got a couple minutes. So that is post-diction, not prediction. And actually, we can see Polaris below the equator at times, which is also a geometric impossibility on the globe. And this is where Occam's razor will get thrown out again, and they'll start making excuses, special pleading, post hoc rationalization, etc. Flight times actually use GPS, which use a preferred direction. They make meridian corrections. So in the south, they use GPS to get the distances. They make meridian corrections, actually subtracting distances over 69 miles and accounting for the preferred direction of C. Actually, the variant nature of C. I hope we get into that, right? If that's what he specializes in. And then, of course, like I said, gravity is not mass attracting mass. That's archaic. So for the last minute and a half, I'm going to explain this. Most people that claim that the Earth's a globe that flies around the sun, they all bring up Newton, the mass attracting mass. You cannot believe in Newtonian mechanics and the heliocentric model at the same time. This is a fact because the Michelson-Morley experiment did not detect the orbit of the Earth. And if there's a force acting on the Earth that causes it to go into a circular motion, you would detect that circular motion with interferometry. That's what the Sagnac effect is. We did not detect the orbit. Einstein came in and saved the day by saying, oh, well, actually, the Earth is free falling in a linear path in the curvature of space-time in a geodesic path. That's why you couldn't detect it, which means, quite literally, either you pick Newtonian mechanics or the Earth is orbiting around the sun. You cannot have both. And in fact, if you do anything with orbital mechanics or aerospace engineering or anything like that, they use Newtonian mechanics. So if that were to even be true, which actually you treat it as an ellipse from our position, that would be evidence for a stationary Earth, quite literally, because if the Newtonian mechanics was true, the Earth cannot be orbiting around the sun. So it's very perplexing as to why people bring that up. Of course, also, it doesn't have a time variable. Gravity would have to be instant. You would have to have instantaneous action at a distance, just like Newton said. He didn't even propose a cause. He said it must be God doing it, et cetera, et cetera. So I know that was a lot. I try not to go too fast. We can get more into the specifics, but Occam's razor is, in the last 10 seconds, obviously that the Earth is a stationary topographical plane and that the Earth is in the center of the cosmos. Everything moves around us for all recorded history. You have to actually make tons of assumptions to explain how those are all illusions. Cool.
Well timed, Wits. Thank you very much, both of you, for your opening statements. Allow me to just welcome our viewers at over 800 strong tonight. Thank you so much for hanging out with us. This is a fantastic showing. It's always exciting to have great debates going on tonight. Flat Earth versus globe. Keep it respectful. Have fun.
Cool.
So, thank you, Justin. Do you believe Newtonian mechanics is true?
No.
Okay, that's correct. What do you know why it's not true, and why it is useful though still?
I don't care if it's useful. It's not true. And
I didn't say it was true either. Why
So
is it
you know
useful?
Because it's really easy to use and simple to use, and we can use it for things on the Earth that I can use like 10 other different equations for.
Because it's made good at predicting the future, right? On our small scale. Oh, no? You disagree?
Yeah.
No. So
It doesn't work on the
projectile motion is a kinematic equation from Newtonian physics. Do you think projectile motion is good at predicting things?
Yeah, sure. We make predictions.
Okay, so you do think it's good at making predictions, Newtonian physics.
Yeah, I just said it can.
You contradicted yourself already. So now predictions.
All right, what's not going to
prediction?
happen is that
Can you
you're
make
going
a
to interrupt
prediction?
me when I'm responding. So you can calm down. You're not tough. All right. So I
sorry.
already acknowledged that it does make some predictions. Okay. Duh.
So it does make predictions.
Duh. But the point is that it doesn't work even on the earthly scale. There are places it doesn't work on the local terrestrial scale.
I agree.
Doesn't work at all on the quantum scale. Doesn't work on the solar system scale, and totally doesn't work on the cosmological scale. I can show you, I need you to pay attention to this. I can give you another equation that does the same thing, and it uses an electrostatic equivalence. Therefore, if our only standard of if it's good or not is if it can make some predictions, then that one's equally valid. We don't even need Newtonian mechanics.
So if it did make a prediction, would that mean it's true? If your equation that you came up with, would that mean it's true?
No.
Correct. So you believe
All right,
Newtonian
you got
physics believe Newtonian physics is very useful and good at making predictions.
But wrong. But it's wrong though.
What about predictions? I know you talked about this, and I hate to get into semantical arguments, but a prediction, can you make a prediction based on past data? What's it?
Yeah, sure. If it's a cyclical
Gotcha.
thing, it's not actually. If it's cyclical, it's not actually a prediction.
So why?
It's just an acknowledgement of a cycle. If you want to
Right.
be semantic and call it a prediction, that's cool. It doesn't.
Okay.
You can't tout it as predictive capability. It was cyclical. The Antikythera mechanism predicts everything that happens in the sky. Doesn't use any type of dynamics whatsoever.
Okay, so it can make predictions. Thank you.
You see how you're
so
gonna
mass
have to be
attracting-
disingenuous?
No, you
with-
said it makes predictions. You said it.
No, I said it's actually cyclical, so it's a postdiction. It's called a
Can you make a
postdiction.
prediction with it?
No, we actually have a technical name for it. It's called postdiction. It's literally what it's called.
Is it telling the future? I don't care what you call it. Is it telling the future?
No, it's
Are you
just it's acknowledging a presumption of the cycle that we've currently observed to that point.
So if you saw a cycle 10,000 times and you are assuming it in the future, it will happen again. Is that what you're talking about?
Right. So then that wouldn't add any
Gotcha.
validity. That wouldn't add any validity to, or like that wouldn't show us that something's valid just because we applied an equation to show us that the cycle's going to keep happening, which was your argument. Your argument was since it matches the cycle, it proves the globe. It literally doesn't.
So it can be used to tell the future, which is what you denied initially in this argument.
No, we can acknowledge the cycle, sure, and we can
tell the
assume the
future.
cycle. We can assume the cycle is going to keep happening. That doesn't actually
So
give
admit
validity
it can tell
to-
the future.
Do you not understand the simplicity in what I'm saying?
You just have cognitive dissonance and don't
Project- you're
pretend.
projecting.
It's so obvious.
Hey.
You can tell the future with it. That's what
Do
you said.
Do you agree that that doesn't show that something's valid if the cycle's going to happen anyway, and then you just create something that absorbs the cycle that doesn't add validity to the claim?
No, it does not prove it's true, but it definitely proves that you can use predictions. It definitely has predictive power.
What do we predict with it?
Did you listen to my intro?
It's not a prediction if I
I showed
already
you
know it's
8
going to happen.
different
Dude.
examples of predictions that the globe Earth can predict that the flat Earth model cannot. So it has predictive power. Would you agree? If something can tell the future, it has predictive power. Would you agree with that at least?
It's not telling the future. We just already see the cycle, right?
So
sure, if you want to be semantic and say like, oh well, dude, this is so ignorant.
No,
to
I
me.
want to stay on this topic actually a little bit because I know you
Well,
just hate this
why are you
so
not-
much. Because I want to acknowledge that you feeling uncomfortable because you're about to admit
I'm
you're
not
wrong about
uncomfortable. This
something.
is I consider this.
Can you tell the future with it?
If that makes you happy, sure.
Okay, so thank you. So you contradict yourself again.
You can also tell the future without it, okay? And so here's the important part. It's a cycle that happens always forever. You can tell the future completely without the globe model. We looked at the sky and we saw that it keeps doing the same thing forever for all recorded history, which is actually a you problem, as you claim compounding vectors that we can just ignore. So then you made a globe model based on the cycle always happening. And it took many hundreds of years to make it, by the way. You had to keep on adding wobbles here and there and just constantly making stuff up to even make it match the cycles that we see. Now people turn around in 2024 and claim that because it matches the sky, it actually proves it's correct when you literally made it from the sky cycle in the first place. That is ignorant.
Right. So that is called deductive reasoning. And I know you're very unfamiliar with that concept, but it's called looking at past data points and fitting a curve, fitting a trend to them, and trying to make a reasonable argument for that trend's existence. So that is called using data.
Cool. Hey, wait. But before you move on,
you're interrupting me.
I just want to make a point. This actually isn't just you going down a list.
Can you not control yourself?
No.
You just
this dude's like acting like I'm here in his
Hold
classroom or something.
Yep.
I'm not.
I understand.
I'm trying to educate you.
That's nice projection. We're about to stick on Newtonian mechanics though, and we're gonna get educated. Why you
don't
can't
believe in Newtonian mechanics? You
can't use Newtonian mechanics. So let's talk about how Newtonian mechanics was disproven with Michelson-Morley. Can you explain how that happened?
I acknowledge Newtonian mechanics is false. I don't have to answer this.
Okay, so then
now, back to the other subject that
we've
been past this. What are you talking about?
So then why do you invoke it? And why do you invoke it?
Invoke because it's useful. As I said, something can be useful and be wrong at the same time. That is the argument I'm making.
Okay, so then gravity isn't mass attracting mass like you claimed in your opener then?
It is mass attracting mass.
It literally is.
You did say this. Does a massive object attract another massive object?
No.
No. So what happens when something is pulled towards each other? What do you call that?
Okay, well, it's not pulled towards each other in your paradigm. I'll happily teach you what happens. So supposedly a mass displaces space-time, causes a gravity well, which causes the bending and warping of space-time, which causes objects to basically be guided through the curvature of space-time, free-falling in a geodesic path, still moving linear from their reference frame. There is no attraction, there is no force, there is no pulling. This is archaic, elementary version of gravity that we teach people when they're in middle school. This isn't what your paradigm believes, and it can't be true if you are orbiting the sun.
Give me an example of something pulling something else.
A magnet.
Magnet. So what about it is pulling it?
The force.
Go on. Explain that a little bit more.
Well, okay, technically on a magnet, it's pressure mediation based on the centripetal divergence and centripetal convergence.
The gibberish again from you, Andrew.
Hey, how is it gibberish? Sorry. Which word did it make sense?
What's it? No, it's not that the words are not words. It's that you don't use them in any usable
Which part of it wasn't usable?
Oh, you want to repeat what you said?
Yeah, centrifugal divergence.
Yeah, go ahead. Explain.
Okay.
Explain it in a way that you think a regular audience would understand.
Okay, so I'll even go really simple for you.
Really simple.
You have a donut, okay? Now we're gonna draw the inside of the donut from the inside to the outside. It's gonna give us, the lines are gonna diverge away from each other. It would be centrifugal, right? Because it's moving out from the center, which is what centrifugal means. Then we have centripetal moving in towards the center, converging. So centrifugal divergence and centripetal convergence are not only not gibberish, they're very simple concepts that are just objective, right?
And
so
yet it's
you
not
asked me
needed
to explain magnetism, and then you freaked out when I used a word with 3 syllables in it.
No.
But yeah, it's the pressure mediation. Actually, there's no such thing as magnetic attraction. It's actually accelerating towards the null pressure created by the actual magnetic field itself. But I want to stick on the fact that you can't use Newtonian mechanics, and you were wrong about what you claimed gravity was, because you were very arrogant in your opener about how we know exactly what gravity is, and it's mass attracting mass, and flat earthers just say nuh-uh, and they have to deny it. You're wrong, my brother. That is not what gravity is in your paradigm. If it was, then the earth would have to be stationary.
So the argument by gibberish is obscure and impenetrable jargon, and a lot of it has to do with using words unnecessarily. You did not have to bring in any form of centripetal nothing when talking about electromagnetism. I've taken many courses in electromagnetism, calculus-based. Thank you. So
okay,
back to Newtonian physics.
How do you explain?
Useful. No. You wanted to talk about Newtonian physics.
Yes.
Newtonian physics is useful and not true at the same time. You can understand things at a third grade level, how they are useful, and yet they are not true at the same time. Would you agree?
They can be useful but not true at the same time, sure.
Yes. So is the concept of gas needing a container, is that a third grade level concept to understand?
Yeah, I would say it's
yes, that's exactly
really
right. And that's why you teach third graders that. And that's why you teach adults grown-up physics, where they don't need a container.
But then why were you teaching a whole room of grown-ups mass attracting mass in 2024?
Because it does attract each other.
It literally doesn't.
By morphing space-time.
That isn't an attraction.
That is a tool. That is a byproduct of the. Does the human push the nails into the wood, or does the hammer push the nails into the wood?
Actually, there's no pushing. Hey, what I want you, or there's only pushing. You're right. Yes, but what I want you to understand.
No, which one pushes the wood, the hammer or the person? Which one?
Both.
Both. So you could say the human pushes the nail in, even though it's not directly by the human, right?
That is not in any way analogous.
Answer my question, yes or no? It's easy. So yes, so the
but
planet
it's not
is causing
analogous.
Deformation in the space-time. Stop interrupting me. You're so rude. Stop deforming.
You're projecting.
Space-time. Interrupting. Justin, is this a problem?
I don't think it is actually a problem. Our audience is here for it. He's trying to reply to you.
Thank you. Thank you. So back to
yeah, you guys are going fine. Just
okay. Back to the argument. If Wits can have composure for 5 seconds, if you admit a human can be the one pushing the nail in, and you don't have to have the most direct tool that it is pushing the nail in, then you can admit that gravity, the deformation of space-time caused by the mass, is also, which the deformation is what's causing the attraction, could also be described as the mass attracting the object. Just like the human pushed in the nail, the hammer pushed in the nail, the mass attracted the other mass, the deformation in space-time attracted the other mass. Semantics. This is such a meaningless waste of time to talk about this.
No, actually, it's very important because when you say mass attracts mass, that's from Newtonian mechanics, and that denotes gravity as a force, right? An innate property of matter, right? And that has been disproven in your paradigm. And of course, even if it were true, you would require something akin to an ether. You would need a medium that's actually giving you mutual contact with the bodies, because there is no time variable in Newtonian mechanics or Newtonian gravity, right? So it's instantaneous action at distance, which is why Newton explained, right? He can't even wrap his mind around it. It must be God doing it. And that anyone that would think that it could act instantly through the vastness of a vacuum through long distances, right? Innate brute matter on other matter without a medium in between them is so great an absurdity that no man with competent faculty of thinking philosophical matters could ever fall into it. So that is very important, because if you're claiming to know what gravity is, you don't need to denote it as something that's been disproven. That doesn't make any sense. So it is important. You're talking, science explains things, physics explains things, math describes things. We're talking about, do you have a viable explanation of physics to tell us that the Earth is a tilted, wobbling, spinning ball flying through space? And the answer is that you do not. So we can't talk about Newtonian gravity. It's irrelevant. You can't have it.
So you cite, again, the Michaels and Morley failed experiment that you always like to bring up that proves the ether, which failed, that was acknowledged by Michael and Morley to be a failed, to try to provide the ether.
Wait,
to grasp again at a fix, again with the interrupting. Control
I thought you were
yourself.
done.
Oh, I never paused. So you cite failed experiments, you use gibberish to try to back up your arguments. And now you're asking me to prove to you again that the Earth is a spinning ball. Can you please acknowledge any other of the 8 arguments I've made in my opening argument? Especially, I would really like to hear about the star moving across the sky. What's it? Why can you see circles in the sky on the south and on the north, and they go in opposite directions?
Okay, I'm happy to discuss your whole list, but not on the heels of you hand-wave dismissing what you clearly were just wrong about. So if you want to be honest and just concede that, yeah, you misspoke when you said mass attracts mass. No, you can't have that. No, Newtonian gravity is no longer an option in your paradigm. You cannot have it. And that Michelson-Morley debunked it, and that you cannot use it, and that Newtonian gravity and the orbit of the Earth cannot coexist anymore. you have to completely change all of physics to believe the Earth orbits around the sun. If you can concede that gravity is not mass attracting mass, that's archaic and elementary and disproven for over a century, then sure, we can move on to something else.
I've already acknowledged that Newtonian physics is wrong. Have you listened to me?
Okay,
I've admitted that multiple times throughout this debate, and you want me to say it again? Sure, I'll say it a million times. Newtonian physics is a approximation of reality. It is extremely useful in all of our day-to-day lives and designs, and it is wrong because it's an approximation.
Only useful mathematically, bro. Can you please acknowledge this? It's only useful mathematically. There is a difference in science and math. Science explains things, math describes things. Okay,
what is something useful mathematically? What does that mean?
Because yes, Newtonian mechanics on like small scales and lower speeds and smaller gravitational presence, right, is somewhat similar to relativity. So, or any time of gravity, it's really just reverse engineered from kinematics anyway. So yes, you can use it.
Use it to do
mathematically.
What? Mathematically. Use it to do what?
Listen, bro, math describes things, okay? Science explains things. You can't, the point is that you need to offer an actual physical explanation. That's what physics is. Of what's going on to show us that it's
useful
possible.
on paper. What does that mean? It's useful on paper. I want you to admit what you're saying. What does it mean?
What do you mean? What does it mean? Yeah,
you said it's useful on paper. What does that mean?
Yeah, we use it to do, for example, engineering. We use Newtonian mechanics.
So predictions.
Sure.
So it's useful to make predictions about the world around us.
Sure.
Gotcha.
But this is the problem.
What I have
I've already said this. I've already said this. There are many equations that could be replaced with that can give you the exact same predictions. In fact, you don't even need dynamics. You can use a kinematic equation to solve for 9.8. For little g, downward acceleration, you can use a purely kinematic equation with initial velocity, height, and time to get the same value. You can use an electrostatic equivalence to get little g. You can use an electromagnetic equivalence to get big g.
Wait, are you trying to say Newtonian physics is wrong?
Well, what I'm saying is that...
Is that what you're saying?
No, what I'm actually saying is if you're going to claim the Earth's a ball flying around the sun and that gravity is causing all the planets to orbit, you need to provide us an actual big boy explanation of it, not just math. We need physics.
Not just math, also observation. That's my entire...
No, we need physical explanation.
So can we move on to another subject? What's it? Are you okay with that?
Wait, this is the problem. Whenever you guys supposedly use satellites and you do all this stuff with satellites, you say that this is what you do. I want to show that even when people study this stuff, that they don't know it. Whenever you supposedly put a satellite up, you use Newtonian mechanics. Well, sure, it works mathematically, but that has huge implications physically. It accounts for real inertial forces, which is specifically impossible. And if Newtonian mechanics was true, right, then the Earth can't be orbiting. So why can't you use Einsteinian mechanics to solve for it? Because it's fundamentally different with the ECI. Because the atomic clocks account for their change of velocity relative to the center of the ECI frame. So you can't use Einsteinian mechanics, but you have to in your paradigm. So if you actually are putting satellites up, all it proves is that the Earth has to be stationary because you have to use a Newtonian mechanics. And do you think they only use Newtonian mechanics to design satellites? Have you designed any satellites recently? I haven't designed satellites, but
that's right, because
I really thought that's what we were going to talk about. That's what you specialized in.
I didn't say I designed satellites, did I? You would know if you did design satellites that they don't only use Newtonian physics. They absolutely use relativity to explain a lot of the motions that they're going to have to go through because, they're up high. They don't obey the normal everyday day-to-day movements that we see on the day Earth, which is what Newtonian physics is. So no, you're wrong when you say they only use Newtonian physics to design satellites. That's patently wrong.
No. Orbital mechanics. Orbital mechanics
that I brought up back in the beginning of this conversation, where I would ask you to explain the rotation of the stars around the poles, please.
I think you're scared because let's wrap this real fast. I want to point out and see if you can answer this. All right. So
I'm not going to answer this. I'm waiting for your answer about the stars. 5 minutes ago when you were disregarding it completely.
You complained a lot about interrupting to have done it basically every time that I say something, but yeah, they claim to use relativity sometimes for stuff like the time corrections, but there's a major problem for you. With satellites, they actually account for, check this out, a preferred direction for the propagation rate of light, meaning that they actually account for a variance in C, and it's provable. We have the actual documentation, right, proving it. So let's see if you can answer this. If the electromagnetic wave, if the propagation rate is actually variant, meaning that c is variant. The speed of light changes in its a preferred direction. It propagates faster east to west. Do you agree that that would debunk your entire model?
With it, I've asked you this question like 10 minutes ago, probably now.
Okay, let's move on.
And
You can't answer.
Thank you. I would like you to explain the stars, the thing I brought up 20 minutes ago.
The stars?
What did I say about the stars? Did you listen or no?
Yeah,
Do you want me to
course.
explain it again? Explain
Dude,
them. Explain the motion they take.
Dude, you're bringing up a day one flat Earth argument, which means you haven't even researched it. So there's many explanations for the stars. One of which is that we have an azimuthal grid of vision. We have a limit to how we see, right? And this is provable. There's been many tests. There's been many tests to prove it, right? That we actually see in curved visual space. For example, the Alley experiments, they actually took another test where they had a sphere with many people with exocentric pointers showing that the way they mapped out the relation to the center was curved. We have curved visual space. We have a limit. We have anticorpuscular rays, etc. All that to say, so whenever you look towards the edge of your limit, what happens is there's an optical convergence, and that would be the southern rotation. And of course, if I'm looking north and I see the northern rotation, if I turn and look south, it's going to look like it's going the opposite way, right? Even if it's going the same way, just because of perspective, it's going to look like it's going the opposite way. And then the question that would need to be answered is, well, why does it look like it's going around the pole in the south, right? And the answer is because there's a convergence, an optical convergence, just like crepuscular and anti-crepuscular rays, right? So when the sun sets in the west, you'll see the crepuscular rays. But if you look to the east, the exact opposite direction while the sun is setting, you'll see crepuscular rays converging to a point over there, 180 degrees away. That proves that perspective will make it look like there's an optical convergence point. That's what we see with the stars. So pretty simple. And there's like 4 different explanations.
It's so simple. So I really like that you brought up this azimuthal grid of vision. Do you have any like models to demonstrate how that works?
Yeah.
Could you bring that up and show us?
You know what the model is. Why are you playing the game?
I want to show your audience. Okay. Right? This is for the audience. So, and I want to show you something else as my...
What's the name of it? What's that goofy dude's name? You know it. What's the name?
It's your model.
You don't know it? You don't know?
No,
you don't even...
I actually...
Someone's going to say
Walter Bislin.
Well, yeah. You've seen it before, right?
Yes.
Okay, so just stick up ahead. You're going to say, oh, how does the light bend like that?
I would like to show the model, please. I would like you to scroll up a little bit.
Oh, you want me to read his description?
That very line, no, a little bit lower, where it says, how does the, you see that?
Yeah, this guy's obsessed with me, isn't that weird?
So this man who created this model does not believe in flat Earth. In fact, he created this model to disprove it, and he knows flat Earth leaders use it to mislead his followers. I want everyone to know that the model you are using to prove your theory was used to disprove it. That's what I wanted to show. So the next thing I want you to do is scroll down to your model a little bit.
All right, dude, I know you think that you're tough on the internet, but what's not going to happen is you're not going to sit over there and act like I'm in your classroom and you're going to give me commands. So now what we're going to do is point out actually what happened is that this guy put this model out attempting to disprove it under his own admission. It was way more difficult than he thought. He ended up showing it actually is viable. Then he had to take many weeks to try to figure out how it wouldn't work. Then he strawmanned the actual stars, not putting the true star data there, but random star points, then making up the idea that they had to go 180 degrees, which they do not. It's inaccurate star positions. Then we started showing this is just the stellarium data. This isn't anything more than him placing stellarium data on a plane. So yeah, we showed it to people, and then he updated it and brought me up. And yeah, he's an anti-flat earther that it backfired. He admitted that it was way more viable than he thought it was going to be, and it was way more difficult to try to disprove it. So you didn't even know about what really happened, and you try to teach the audience about what happened. But
is the model valid or not?
It's a possibility. Yeah, it's one possibility.
Okay, thank you. So now please go to the actual model and go to change the ray parameter to plus 200%.
Why?
Because I want to show you something about your model. All right, and now make the dome grid checked on, and the stars checked on, and the dome ray checked on at the bottom. Yeah, check dome, dome ray, stars, dome grid.
They're all on.
And make observer latitude -90.
-90.
Right.
You know,
now, I would like for you to look at the model from the side view.
Why? How is this relevant?
I want to show that your theory requires stars on the opposite side of the planet to exit the dome, and the light comes back down to you 180 degrees in the opposite direction for you to try to literally bend over backwards to try to explain the observations that are seen on a daily basis on this Earth.
Incorrect. So where you actually have this, of course, is at the furthest edge of Antarctica. And these, of course, are not observed date. These, of course, are not, they're, of course, not observed daily there, right? The southern star trails, mate, where's the 90-degree zenith angle measurements?
Well, this is what your model is saying.
I'm talking. Did you hear me talking? Okay, so you made me go to 90 degrees. What I want to know is, where are the 90-degree zenith angle measurements that verify this observation that you just falsely claimed are observed by everyone every day? Where's the actual, there's not one that exists. Not one time.
So what you're saying is this model is wrong, which you just said it was true.
What I'm saying is when you go to the extremity out here, this actual observation doesn't exist.
So this model's wrong.
Yeah, the model's wrong at the edge where we don't actually have observation.
Crazy. Where we just said the model was right.
Where we don't actually have observational data, but when you take it where we do have actual observational data,
for example, Southern Africa.
Every time I'm talking, you interrupt. Why would you have the audacity to complain about it?
Southern Africa.
Okay. So, like, you notice how ridiculous you're being, right? Like, you're interrupting me. I'm just going to finish my point. So, in reality, we don't make observations here, right? So, we make observations in different places. So there are many potential explanations for the southern stars. This is just one of them. There's just one of them. There's another person you can look up if anyone actually is curious. It's Tomb of Illumination. Used to be Flat Earth Philosophy, and he breaks down the actual quadrant, the optical projected quadrant in the back or in the sides. Also, someone's taking a dome, projected stars onto the dome, and shown that the exact stars will be in the south, just completely reflected as a projection to the south. It's been replicated that we would see southern star trails on a flat Earth with a dome, with an azimuthal grid of vision, and with a projection, with like a electromagnetic polarized holographic projection. People can think that's crazy. It doesn't matter. It's objectively, there are many ways to explain the southern star trails. This is a fact.
My turn. So your criticism is people don't live on Antarctica. It's not regularly observed. So
it's never observed.
This specific situation is invalid. Let's go a little bit. Let's bring the latitude a little bit more north to southern Africa, and then look at it from the side view.
Okay, now
are these real? People observe every day. Would you acknowledge that?
No. Are these real stars? Are these real star positions?
You're not going to show it.
I just showed it. What are you talking about?
You're not. It's from the side. You don't want to show it,
dude.
A little bit more, angled down, where the Earth is, and more to the side where the observer is on the side of this hemisphere. Okay, so in this specific situation,
want to show it.
I acknowledge the light doesn't, in this case, exit the dome, but you can absolutely see that the stars definitely do still go 180-degree curve from one side of the planet to the other side of the planet, and then back into your eye. That is Occam's razor, if I've ever heard it.
Okay, now let's say the same thing I already said. Are those actual star observations, or are they random arbitrary stars that he decided to draw lines to? What's the answer?
You know the answer, and this is your model.
The answer is that it's not even actual observations.
Obviously, it's a model.
So no, you don't have to see that. You don't have to see that.
The model is.
No, you don't have to see that. Right? No, we like the model without the stupid little lines drawn on there. That was, he admitted that this was the only way he could figure out how to try to disprove it, because he was surprised at how well he was able to make it work on a flat Earth. And he actually then arbitrarily drew the lines. His argument is light couldn't bend like that. Been like what? Your straw man version of fake observations that don't happen in reality? So this is completely backfired on you. Of course, there's substantial evidence that we actually see in curved visual space. So the real question is, why doesn't your model account for what can be experimentally proven, which is that we have a curved visual limit? Right. Which means actually your model's impossible.
Can I go? Is it my turn?
Yeah,
Okay.
acknowledge what
So,
I've said.
so if there was a star, and maybe it is not in the exact same location that is on this model because it is a model, but if there was a star on that side of the dome, what's it? Do you believe that the light from that star would go to the other side of the planet, take a 180-degree turn back, just so it can go into your eyeball and you can see a star from the opposite side of the planet? Do you believe that that is how your model works?
No, that's not a real
So
observation.
this model is wrong.
The arbitrary lines he drew to fake stars that aren't real observations is wrong. Yeah,
So
I
if there's
just
an
said that.
actual star in that location, do you think that would happen?
But there's not.
If there was, what's it? Did you hear what I said?
So you're saying,
Are you ignoring me
wait,
on
wait, so you're
purpose?
saying if we made observations on the Earth that we don't, would the model not work? The model wouldn't work if there were observations that don't exist. That's correct.
Witsit doesn't want to acknowledge the fact that his model forces, literally bends over backwards, the acronym to describe arbitrary thinking, the light of these stars to absolutely bend over backwards just to explain the observations seen at the Southern Pole. As I explained in my introduction, you can absolutely see the Southern Cross, whether you're on point D or point E of my presentation. Please go back if you don't remember. On both sides of the Antarctica, you can see the Southern Cross. To explain that on a flat Earth theory, you have to have absurd forms of optics that the light can turn 180 degrees just because you observe it.
Okay, now again, these aren't actual observations that you have to see from 180 degrees. That's nonsense. This entire thing is not even reality, and I'm gonna stop sharing it now. And like I also explained, there are multiple explanations of the southern stars, right? So there's an explanation that there's actually two, just like it's called magnetohydrodynamics, right? That you would actually just have two actual rotations, and that we would see the center point. You would have to actually go to the south and explore more adequately, because that would significantly change certain layouts further south, which, I mean, you know, that's an interesting point. The third one is that it's actually a projection, and that it projects equally out into 6 quadrants, which can be replicated, has been replicated and recorded. We've replicated this. So we get, you think it's not possible, okay? I'm telling you that it is possible. We've replicated it in physical reality. And what I want to know is, how are we going to address all the stuff that falsifies the globe? That's what I want to know. Because if I'm like, oh, well, this guy arbitrarily says he doesn't agree with some of the explanations that Flat Earth has. Okay, cool. You were wrong. We do have possible explanations. So let's get to the evidence that falsifies the globe. Because you agree that if there's tons of evidence that falsifies the globe, and then there's possible explanations for this on a flat Earth, and we're still stuck with a flat Earth, right?
Yeah, let's get to it. Let's get to the stuff that disproves the globe. His explanation again was magnetohydrodynamics. Again, impenetrable jargon, argument by gibberish, no explanation of it. So I want to talk about the thing you said before I started talking, where you were saying that the stars travel in the same direction on the poles, whether it's north or south, because you're just confused, right? It's an orientation issue. So this is obviously going to disprove the globe. So could I please share my screen to discuss this?
No, I'm sharing my screen. You just claimed that this word was impenetrable, made up jargon, garbage.
No, I didn't. I didn't say it was made up. I said it was impenetrable because you didn't explain it. You didn't explain the point you were trying to make. That's what I said.
Okay.
You misrepresented my point. Another straw man from the flat boy.
So you think big words are just gibberish?
No, it's called impenetrable because you know your audience isn't going to understand it. What's it? Keep up.
No, I actually explained. I literally explained it right after saying
you didn't. You stopped explaining that one and started explaining a different subject.
I said that would mean there's two. I would say that means that there's 2 actual rotations in the electromagnetic field. I literally said those words.
Oh, well, I guess the audience will decide when they'll rewind the paper or rewind the video. Could I share my screen to talk about the thing that's going to disprove the globe?
So it wasn't actually impenetrable garbage. That's interesting.
It wasn't at all. You're so right. So can I share my screen, Justin?
I'm trying to stop sharing. It's like
I want to disprove the globe right now.
Oh, dude, it's saying that the Zoom meeting is not meeting. Can you still hear me?
I can still hear you.
You're still here. Everything's working good.
I'm not frozen or anything?
No, you are not.
Okay, it's saying that the Zoom meeting is not responding, so it's like telling me to close the program.
It's okay. I can stop it here. If you need to refresh Zoom, that's okay as well.
Yeah, I might have to just come back.
Yeah.
Is it still saying I'm sharing screen?
No, I stopped your
No.
screen share for you.
Oh,
Okay.
let me
And
share
you're
my
still
screen now.
actively here.
Okay.
I'm just like frozen.
Just hang
on my
on. Just
screen.
hang on, William. Don't go.
Well, if he's gonna share
sharing-
screen, I can drop and come back. If you're gonna put his screen up, that work? What up, bro?
We're so nice to have you back. So yeah, the audience is electric. You guys are doing a fantastic job. Everyone's loving this. We have about 10 minutes left before Q&A. So
Okay.
I will let you boys continue.
All right, can I share my screen now?
Well, sure. But real fast, William, you understand that you're just going through all your points, and you still didn't acknowledge the one argument I made in the opener, and you're also avoiding all the direct refutations of your arguments.
Oh yeah, I acknowledge that for sure. So back to the globe model. So this is going to disprove the globe as Wits has already described. So the flat Earth model, you acknowledge, Wits, that the stars are rotating in are in the same direction versus the South Pole versus the North Pole on the globe model. You'd say it's the same direction, right?
Say again.
You said the stars are rotating in the same direction when you're in the South Pole versus in the North Pole due to your azimuthal grid of vision. We're seeing that it's going the same direction, right?
I said that they move in the same cardinal direction, but they move clockwise and counterclockwise.
Gotcha. So different directions.
Because of optics. Do you disagree that if you
Different
look the
directions.
opposite way, something's going to look like it's moving the opposite direction?
I absolutely do disagree with that because we have something that exists called the right-hand rule. And Wittensit likes to not tell his followers that this is a very normal principle in physics, that the right-hand rule gives you an orientation that allows you to not be confused about things like that. When he says something like, people get confused between a 6 and a 9, that's the same as being confused of which direction the stars are going in the north and south. No, we know it's two different directions, and it's not just a confusion based on your orientation. Because you can, when you go in the north and you observe the right-hand rule, you curve your fingers in the direction of the curve of the stars, your thumb will point up. And if you go in the south and you curve your fingers in the direction of the curve, your thumb will be pointing down. They are not going in the same direction by observation. Right? What's it? You agree with that, right?
Dude, that's crazy that you thought that was a good point. So,
do you agree or no?
No, of course. So I don't agree. The direction of current is actually what that's about, which is funny, right? The right-hand rule is actually about the direction of currents. You don't want to talk about that, though. Let's not talk about that because that actually works perfectly with the flat Earth. That's crazy. The right-hand and left-hand rule work perfectly with the flat Earth explanation of a singular motion, a singular direction, actual direction, and then a downward electric current. But what I'm explaining to you is if everything's actually moving in one direction, but then I look the other direction, it will objectively look like it's going the other way. You're saying that's not true. And then you brought up the right-hand rule and said, if I assume the Earth's a globe, and I put it, we all understand why the globe claims they look like they're going the opposite way. On the globe, all the stars are going east to west, but we're upside down relative to the northern position, so they look like they're going the opposite way.
Gotcha. So do they move in the opposite direction?
In actuality, they all move in the same direction, east to west.
In actuality, but how about in observation?
There's a difference in the observed, in the actual card.
Because what's in actuality can be up to interpretation, right? But what's in observed is much more objective. So what do we observe to be true?
How do you not understand what I'm saying? Which is that all stars moved in the same cardinal direction.
So,
do you agree?
Same cardinal direction. Go ahead and explain that.
All stars move east to west.
There we go. So when you're in the north hemisphere, they're going in one direction, and when you're in the south hemisphere, they're going in the other direction. You would agree?
Yes.
So they do go in two different directions.
No.
When you are in the different locations.
This is so crazy. This is like Flat Earth 101, bro. And this is what he's going to eat up the last 10 minutes. He doesn't want to address my argument, but I'm going to say it one more time. All the stars move in the same cardinal direction, east to west, right? But there's an optical perceived direction, which is clockwise and counterclockwise. If every star was moving around Polaris and you look south, they would objectively look like they're going the opposite direction Objectively, it can be replicated. You would have the optical convergence point like corpuscular and anticorpuscular rays, which he conceded exists. I want you to address the actual electrical field argument. We've talked about like all of your arguments. I'm going to talk for a second now. You didn't concede to the retrograde. You claimed retrograde proves we move around the sun, even though there's a kinematic equivalence with retrograde, even according to relativity. That's absolutely not true. Parallax, aberration, and retrograde, kinematic equivalence all work with the Earth being stationary. Would you like to concede retrograde doesn't prove the Earth orbits the sun?
No, absolutely not, because what the globe model predicts is the retrograde movement, right? We could predict that even if we didn't see it, right? If we imagine just a brand new planet that joined our solar system, we could predict the motion it would move. We would predict what retrograde motion we would see with that new planet. It's a predictive, it has predictive capability.
So does a geocentric model.
No, it doesn't, Austin.
It absolutely does. It's
you have said multiple times, your entire model is founded on the fact that, yeah, we see it multiple times in the sky, so we can maybe make some predictions about it, but we can't really do any further than that, because we don't know what it is, we don't know why it's moving, we don't know where it's going, we don't know anything about it, we just know we see it. We know more than that. We see it, but we also know more.
It's called the Neo-Tychonic model, okay? And it absolutely has the same exact kinematic predictive capability for retrograde. This is very basic stuff. If you would like to read a paper on it, I'm happy to send it to you, right? It's called the Neo-Tychonian Newtonian Machian Analysis of Planetary Motion. It's not complicated. But now, so you're wrong. If you think retrograde proves the Earth's orbiting the sun, I wouldn't be talking down to so many people like flat earthers are just ignorant. That's very basic stuff. There's a kinematic equivalence according to relativity. So that means all astronomical observations can be validly explained from a central position. Go read some Stephen Hawking. He'll tell you the same thing. But what I want you to do is address my one argument I made, which is that we have a vertical electric field on the Earth with equipotential lines, and that this requires two Gaussian surfaces that are parallel to each other and perpendicular to that. And since we have a uniform electric field, you cannot have that on a sphere. You cannot have uniformity of a vertical electric field on a sphere. It's physically impossible. Therefore, proving that the Earth is not a sphere and that there is something acting as a second Gaussian plate above us.
Gotcha. So I will acknowledge what you're saying. The first thing you said, what was that model that you described that would display the retrograde
It's called the
motion?
Neo-Tychonic model, or Neo-Tychonian model.
Gotcha. And you will admit you didn't explain what that model was in this debate,
I
right?
did already explain it. I said
Oh, you explained it? Do you think everyone in this debate, or
yes,
most people would understand what you were saying?
Yeah, and I'll repeat what I said already.
Gotcha. So everyone who's listening right now, if you don't already understand what the Neo-Tychonian whatever the hell model that Wits had just described is, if you don't already understand what it is, then he knows he's taking advantage of you.
Okay, so I already said what it is, which is the Neo-Tychonic model is all the planets moving around the sun as that whole system moves around the Earth. I did explain that if you can just think about it for a second, you would know that would give you the exact same explanation for why the planets look like they're going backwards in retrograde. It's called the Neo-Tychonic system. Tycho Brahe's system, of course, was here before any other heliocentric model. It's a slightly updated using Machian principle. Here's the paper. Can I share the screen? You're just showing your, can I share my screen to the paper, please?
Yes.
To be fair, you may have missed it, but I absolutely did explain that. And if you think about it, it makes very simple sense. Oh, am I not sure? Yeah, okay. The Newtonian Machian Analysis of Neo-Tychonian Model of Planetary Motions. It was published by the European Journal of Physics. Last time I did a debate on this, people claimed that it wasn't a real paper, so I just wanted to show it. This is the paper. And actually, if you want it, I can get it for you. I have the actual PDF. Okay, and anyway, and it's not even like that simple. It's not that complicated. Please don't freeze again. Okay. Yeah, do you understand what I'm saying? If all the planets moved around the sun, and then the sun was moving around the Earth, from the Earth's position, as the planets move around the sun, it would look like they're going backwards from our perspective, which is the same explanation the heliocentric model has for retrograde.
So your entire argument is that everything is moving the exact way our gravity predicts, except we want to be the inertial ones? Is that your prediction?
First of all, we have
That's what you just
scientifically,
said, right?
we've already scientifically and experimentally proven that the Earth is a stationary lab frame with interferometry. Your gravity doesn't predict the
I
planetary.
asked a yes or no question, but I was thinking you're saying yes. So
Yeah,
what you're saying
the Earth is inertial
everything,
provably. That's what I said.
everything looks just like as if they were a bunch of planets orbiting the sun. It all looks like that, and it very well might be that way. Also, we're not orbiting the sun.
Well, no, actually, it only looks that way because we created the system over time, right? And it still doesn't even work. We have the Mercury perihelion shift. It doesn't work. It doesn't even work with your model or with any version of gravity that's ever been proposed, right? It doesn't work. But yes, what we saw was that there are something called stars and then planets, planae, wandering stars. They move a little different and they move seemingly backwards from our perspective. I explained two options. One is that we actually measure the motion, right, in relation to the background stars. So if the planets periodically slow down in relation to the background stars, it would look like they're going backwards. It would cause retrograde. Secondly, it could just be that the planets move in relation to the sun that moves around the Earth, and that would give you retrograde. So now we're going to go to the actual empirical measurements on the Earth that tried to measure the motion of the Earth that is claimed and prove that the Earth is not orbiting the sun, and Michelson-Morley requiring Newtonian mechanics be thrown out, and Einstein saying, turns out everything that happens on the Earth is going to happen like the Earth is in a state of rest. You'll never be able to disprove it's in a state of rest. You'll never be able to measure or detect the Earth moving through space. That is your current position. So if we're going to use Occam's razor, that would mean the Earth is, of course, at rest. You're going to claim it's an illusion. So you don't like Occam's razor. Occam's razor destroys
I do like Occam's razor. I do love Occam's razor because mine requires so few lesser assumptions than yours. You are literally trying to say everything on it all looks like it's orbiting the sun, but we're not. We're the inertial ones, but everything else is orbiting the sun but the sun is orbiting us. That requires an unbelievable amount of cognitive dissonance. What's it?
No. Address the point. Address that the measurement showed the Earth is not.
The Earth
the measurement showed the Earth is not moving around the sun. And what your position did, if we're going to apply Occam's razor, if we use highly precise interferometry that should be decisive, quote unquote, from Einstein, over 10 times more sensitive than it needs to be to detect the orbit of the Earth, and it shows the Earth is stationary, Occam's razor would say the Earth is stationary. What did your side do? Throughout all of physics, throughout Newtonian mechanics, came up with a brand new idea of 4D space-time geometry that bends and warps. And actually, even though we're curving around the sun, we're not curving, we're going straight. We're going straight in an orbit, and then we're free falling through a geodesic path, and we weren't able to detect it because it's just linear motion and the interferometry can't detect it. But then in 2004, we actually detected linear motion with the interferometry by weighing, which even disproves that explanation. So there is no way the Earth is orbiting. It's a fact. So your subjective opinion of how you think it's cognitive dissonance or it's convenient doesn't in any way combat the physical empirical measurements. So have you researched any of that?
Are you ready for Michelson-Morley?
Yeah. Michelson-Morley.
Sorry,
hold on. So we're pretty much at the end of our open discussion. In fact, we've gone over a little bit, and I know that William, you really wanted to have like a closing statement. So, yes. I will allow. How much time do you think you want there, William?
A minute or two.
So I'm going to allow you a closing statement, and then I'm going to return the exact same time to Witsit to have the final word, and then we'll go into Q&A. Okay?
Awesome. Thank you.
No, you're welcome. All right. And
everyone.
It's all yours.
All right. For my final argument, I want to talk about this man, Mike Hughes. Mike Hughes was born and raised into a loving family in Oklahoma City, and he killed himself on February 22nd, 2020, for the cause of flat Earth. And if all of the audience tonight truly want to challenge their perspective and try to discover real truth, please do not watch another flat Earth documentary that's trying to prove flat Earth wrong. Do not watch another one of those. Instead, watch a documentary about Rajneesh Puram, or Max Nexium. That's supposed to say Nexium, sorry, with an N. Nexium, watch Regnish Purim, or Nexium, or Love Has Won, or Heaven's Gate. Watch documentaries about these things and other things like them, because one person has already died in the name of flat Earth. We do not. We want to ensure that this never, ever happens again. Thank you. That's my final argument.
All right, Wits it. You can have the final word. It's just over a minute, so it's all yours, bud, and then we'll get into Q&A.
Mike Hughes supposedly was a flat earther that wanted to prove the Earth's not curving and shot a rocket up, not even higher than the highest building on the Earth. And we send balloons up. We send balloons up over 100,000 feet. What's even funnier is he's on record admitting he's not actually a flat earther, and all the people that were with him making the movement to raise the money came out and said it was just a PR stunt to try to raise money. He didn't think the Earth was flat. So a globe earther was dumb enough to think it made sense to claim going lower than the highest building on the Earth would prove flat Earth, to try to raise money and lie to people. So that's a very underhanded tactic. And what we proved is that retrograde was wrong. What we proved is that the lunar eclipse is a geometric impossibility on the globe. What we proved is that you couldn't even address for a second the vertical electric field on the Earth, and that you don't understand the MMX, and then subsequent interferometry measurements prove the Earth is not orbiting. The truth is that the Earth is a stationary topographical plane. All you did was look at the cycle of the sky, reverse engineer a model, reify, presuppose, and affirm the consequent, and then hand wave dismiss all empirical measurements. So that is a summary of the debate.